Thanks everybody for your time today. I want to talk about my experience working in and around the blockchain ecosystem in two different settings, in the White House and in a startup. And what most people think when they hear that I've done both of these things is that, wow, these are really different settings. You're dealing with different people doing different kinds of stuff, very different environment. The White House, very slow and stodgy and formal. Startup, not so much. Actually, I think things look a little bit different when you're actually in those places. But I want to talk about both of those experiences and the different ways in which people in both of those places are working to try to make sure that this technology is actually developing the way it needs to help people. And so let me start by talking first about the White House. So like I said, the White House looks kind of different when you are a person who goes to work there. This slide here shows the employee entrance to the West Wing. The low white building in the front is the West Wing, which is where the president and the president's senior advisors have their office. You can see the Situation Room from here and the Chief of Staff's office and a bunch of other things on a typical sort of rainy, clearing up Washington morning. So it is a different kind of setting. And when you think about what happens at the White House, you probably think about things like this. Here's me in the Oval Office briefing the president about a technical issue. This is a sort of terrifying experience the first time you go in there and sit on that actual couch in the actual Oval Office, talk to the actual president. It seems kind of surreal, and the fact that there's a guy in the corner snapping pictures of everything doesn't help. So you might think about this as being what happens in the White House, and it kind of is. You might think about this as being the kind of thing that happens in the White House. This is a Situation Room meeting with members of the cabinet and the president's most senior advisors around the table, and then staff members around the wall. If I was in a meeting like this, I would be one of the people along the wall, although it was not an everyday occurrence to be invited to a meeting like this. So there is a lot of this kind of thing that goes on. There's no question about it. But in many ways, the actual day-to-day experience of working in the White House is much more like a startup. Here is the actual I worked and some of my colleagues, right? This looks a lot more like a startup. The only thing that is maybe non-startup-y here is the guy in the suit. DJ Patel's wearing a suit that day. Probably he was meeting with somebody important who would get unhappy if we dress like the techies. But if you look at the three folks in this picture, the guy in the suit and the woman with her back to the camera are both now startup founders, as well as the photographer, me. The guy at the computer over on the left, he's now a state legislator in Virginia. But these are people who came from startup land. These are people who went to startup land, and we worked in the same kind of way. So, you think about the White House as being, say, a very slow and bureaucratic place. But I can tell you that they went from, with me in hiring me, from the first tentative conversation about whether I might possibly want to work there to a job offer on the table in a week. That included interviews and all the process and decision-making that needed to be done there. They can move really fast and in a very nimble way when they want to. And it is kind of startup-y in a way. And people do the sort of startup things. You see over here on the right, there's this big poster board with Post-its on it that get moved from column to column as a project makes progress. People write things in the corner of their whiteboard. This was the corner of my whiteboard on the day I left. With our administration scorecard, we're trying to keep our focus on the metrics that are really important here. Have we broken the internet, and have we avoided the robot apocalypse? And we were happy to have a completely clean record for 8 years on that, although I was only there for the last 2 years. It's also a place where people do technical stuff. There were a few hundred very skilled software and technology developers who were on the White House staff as part of the US Digital Service. This is a place where some of the most accomplished and senior engineers in the tech world can come and do a 18-month or 2-year tour of duty. We did these hackathons on a regular basis. People were really interested in building stuff. People were really interested in cryptocurrency technologies. So, and there was a lot of really forward-thinking discussion about how government could use blockchain tech, about questions like why and when might it make sense for the US government to issue a digital dollar. All of those things were already in the mix, in the discussions inside the government in 2015. Although the government doesn't often speak publicly, often doesn't speak with a clear voice about what people are thinking, there are smart and forward-thinking people there who really are sweating these issues. And there's a lot of interest in and attention to this topic. Now, that said, when you sit within the government, or especially when you sit within an agency, you have a mission. Your agency has a mission which you are trying to do. And you're going to focus on that mission, and whatever the topic is that you're thinking about how does it affect that mission. So for example, the people in the Department of Transportation who are in charge of auto safety, they come to work every day and think about how many people in the United States die on the highways every year. They come to work every day and think about how can we make that number smaller. And so while you may be thinking about a car in a more holistic way, it's the job of those people to think about vehicles and to think about traffic and how people behave around it, purely from a safety standpoint. And that's the part that they play in the ecosystem. So the same thing is true in finance. There are regulatory agencies, there are agencies that are responsible for fighting international organized crime organizations and so on. And they are going to look at this technology through that lens, and they are going to be looking to try to understand what they can do to make sure that that those aspects of the technology that might be dangerous to their legitimate mission is not able to happen. And so when you talk to someone in the government, it might seem to you like they have a very narrow view, but the fact of it is that there are people all across the government who have different missions. And when the government as a whole makes a decision, when the White House convenes people to come together to make a decision about what the policy is across the whole government, that's when those different views and those different missions come into contact and dialogue with each other. And that's where you can get your eyes on the whole picture. And I was continually amazed by the ability of the government and the ability of senior decision makers to really be able to look at a big and complex issue like this from all directions and to form a real holistic view of how can we get the benefits while snipping off those few areas that are problematic. So in an area like blockchain tech, people are really excited about the opportunities for innovation, about the competition in financial markets and other places, the flexibility and agility that it can bring. But at the same time, they recognize that it's an area that is open to scams and to other forms of dangerous behavior. And they're constantly thinking about what to do about it. So I spent about 2 years doing that. It was an incredibly exciting and rewarding experience. But then January of 2017 came, and it was time for us to leave and hand things over to a different team. So I went from the White House to academia. I turned back into a professor of computer science at Princeton, which is what I'd been doing for a long time before that. I did a bunch of stuff there, went back to doing research on blockchain and cryptocurrency, worked with a bunch of folks, including Stephen Goldfeder, who eventually was one of my co-founders in Off-Chain Labs, to build, to write this textbook, which is still used at about 200 universities around the world. I worked then with Stephen Goldfeder and another student, then student Harry Kolodner, on this project called Arbitrum, which we were really excited about to look at what you could do to try to improve the scalability of smart contracts. And that eventually led to me moving from the academic world to a startup, namely Off-Chain Labs. We took that academic research and we spun it out into a company. And the three of us then moved into being full-time at the company, building a team, raising money, and all of those things. So that is the startup experience, something that I'd been involved in a peripheral way as an advisor to companies, but something I'd never myself done before. Okay, so I want to talk about what our vision is and what we've been doing to try to attack what I think is one of the most challenging limitations on one of the most exciting technologies in this space. And in particular, it is what can you do with smart contracts? And in that space, obviously, Ethereum is the main player. So when you look at what this technology needs to succeed from the standpoint of technology and markets, I think there are four basic building blocks that you need to provide. You want to have smart contracts, something that can run any computation. That is, it's nice to be able to do things like simple token transfers, but it's much nicer if you can actually build the whole ecosystem of services and tools around that. So you want to be able to run any computation. You want to be able to do it trustlessly. Otherwise, why are you on a blockchain at all? You want it to be scalable so you can do a lot of it and a lot of people can do a lot of it. And you want it all to operate at low cost. And right now, if you look at what Ethereum can do, I think it's fair to sort of grade it this way. For smart contracts in generality, great. Trustlessness, great. But when it comes to scalability and low cost, not so much. And the fundamental problem there is that every Ethereum miner needs to emulate every step of execution of every smart contract. And that becomes a real bottleneck. And this is where technologies can come in, because layer 2, if done right, can preserve the benefits of Ethereum, but can attack those scalability and low cost barriers. And I want to talk a little bit about how we're doing that. So we have this layer 2 technology called Arbitrum that we're building. And Arbitrum is building a kind of chain, a separate chain, which runs on top of Ethereum. An Arbitrum chain consists of a series of blocks of transactions. You can imagine the Ethereum chain is this blue line at the bottom of my slide, which helpfully is already there in the design. And on top of that Ethereum chain, we run a couple of smart contracts, which are the sort of administrators for this Arbitrum chain. And the key here is that almost all the work is done off the Ethereum chain, but these contracts do just enough to make sure that your Arbitrum chain is able to run with all of the security of Ethereum. So their job is to notarize the progress of the layer 2 chain and to resolve any disputes that arise about what the layer 2 chain does via an efficient dispute resolution protocol. The other parties who play an important role in the operation of this thing is validators. Every Arbitrum chain has a set of validators. It's permissionless, so anyone can be a validator who wants to, and their job is to watch the chain, to make claims about what the chain might do, to challenge other validators' claims if they're wrong, and then to participate in dispute resolution when it happens. So this entire ecosystem creates a situation where the validators can do the vast, vast majority of the work, and yet the smart contracts that run on Ethereum with the security of Ethereum do just enough to make sure that the validators stay on the straight and narrow and make the chain operate securely. So the validators track the chain's progress and challenge any false claims. All right, so we just about 3 weeks ago launched the Arbitrum Test Net. And it is the first off-chain roll-up technology that is generally available to everyone and can run smart contracts. So what does it do? Well, we move computation and storage off-chain in a way that's trustless. The L1 Ethereum chain is able to just does enough recording and dispute resolution to make sure that the computation and storage are done in the right way. That's why it's trustless. We've built this in a way that requires no changes to existing dApp code. So what that means is if you have an application that's written in Solidity or any language which compiles to the EVM, the Ethereum virtual machine, you can just load that directly into the Arbitrum testnet and it will just run. You don't even need to recompile it. So there's no special tooling that you need to use it. To deploy a contract, you send literally the same bits that you would send to Ethereum. Only now you just send it to the Arbitrum chain. You can deploy any contract on the testnet whenever you want. You can go and do that right now, but please wait till after I'm done talking. And we have a big cost advantage over Ethereum, 50 to 100 times reduction in the cost of doing a transaction. And the reason for that is because we move almost all of the costly aspect of doing an Ethereum transaction into this off-chain space where it's vastly cheaper. And I'll show you an example of an application that gets that kind of cost advantage in a few minutes. You can get up to about 4,000 transactions per second for Reddit type workloads. If any of you were following the Reddit scaling bake-off, this thing that they started up in August, using the Reddit workload, we estimate you'll get about 4,000 transactions per second on Arbitrum, vastly more than you can do on Ethereum. And then finally, you get to trustless finality as fast as Ethereum. Our engineering team has worked really hard to build a system that has all of these desirable properties without giving up trust or security. So that's pretty cool, but can we add another zero to that? Yeah, we think we can. We think we can get to ultimately, not with our initial product, but with the next generation that's now in our heads, and we'll start engineering after our mainnet launch, called Arbitrum sidechains. We think we can get to 1,000x cost advantage over Ethereum and up to 40,000 transactions per second with that system. We think that's possible. We think we know how to do it. And that's something that's on our roadmap. Okay, so how did we do it? The answer to that essentially is by looking at, in these systems, what gets done where, which functions of the system get done in which place. Some things get done on legacy computers, people's laptops or Amazon or other elastic computing resources. Those are super cheap, super fast, but they can't be trusted, or they're not trustless. One thing you can do to get around that, the Ethereum approach, is to do work at layer 1 on the Ethereum main chain. That's trustless, but it is expensive. And that's, of course, the problem that we're trying to solve. Layer 2, on the other hand, a system like Arbitrum, where computation and storage is moved off-chain but without giving up security, that's trustless and cheap. So if you want to figure out how you can drive the cost down without sacrificing trustlessness, the obvious answer is to figure out how to do as much as possible of the work that's involved in operating your system at layer 2. And that is where we've done, I think, a bunch of really innovative research to try to drive the overwhelming majority of the work that needs to be done to operate an Ethereum compatible chain in a trustless way up into layer 2. And one of the components here that does that we're really proud of is something called ArbOS. And ArbOS is a piece of software that runs entirely at layer 2, entirely off the Ethereum chain, but with the trustlessness of layer 2, and operates as a kind of operating system. If you think of each chain as a kind of virtual machine, as its own little computer that is emulating, operating a bunch of smart contracts, ArbOS is the little operating system that runs there. It manages deployment of contracts, tracks who owns which ETH and tokens. It protects contracts from each other so they don't stomp on each other's storage or other things. It does resource accounting, make sure that contracts don't use more gas than they're supposed to, make sure they pay for their gas. It does various things related to compression and batching of transactions for efficiency. And it does all of that cheaply and trustlessly at layer 2. This is one of the really important innovations, and it's this kind of work that is going to make layer 2 successful. It gives you the low cost of doing all of this work, which in traditional systems has been done expensively at layer 1, and to do it at layer 2 with that low cost, but to maintain the trustlessness. Okay, so just yesterday, we rolled out our first major application demo on top of our open testnet. As I said before, the open testnet's been up for about 3 weeks, and it has the attributes I was talking about before. But just yesterday, we launched a full port or clone of Uniswap, which we took to calling Arbiswap. So this is not a product of the Uniswap organization, but it is their exact open source code ported to run on top of Arbitrum. And if you see the URL up here at the top, and I'll give this to you again later in the talk, you can go there and you can use it. And it has the same functionality as Uniswap. You can, it essentially is a fully automated exchange that lets you trade ETH against tokens or tokens against tokens. This version is running entirely at layer 2. So we did this in order to show two things. First of all, how easy it is to port an application onto Arbitrum. And you can look and you can compare this Arbiswap against the Uniswap contracts and user interface that we started with. And we did make a few changes to the user interface so that it was a little bit more evident what's happening at layer 1 versus layer 2, but relatively minor changes. We changed the logo up in the upper left here and so on. But this is essentially the Uniswap application running on Arbitrum. And what's really important about this is not only that you can go try it yourself, but you can see what the cost reduction is from doing this. And when you do this, a typical swap or trade um, transaction costs about 1/50th. That's a factor of 50 less, 50, less than it costs on layer one. So you go from over 100,000 gas to something in the neighborhood of 2,000 L1 gas in order to do a transaction. And you do that without needing to change the smart contract code that actually executes here. So we think that's a big win, and we think this is a great feasibility demonstration. But of course, what we really want is for those of you who are developers to go and try out your applications on this system. Okay, so what's our roadmap going forward? We had a fully functional test net that we launched, as I said, 3 weeks ago, mid-October. The Arbiswap demo, this fully functional Uniswap port, we stood that up yesterday. And we'll have more demos and more features that we'll be rolling out in the coming weeks. But probably most importantly, we'll have a release candidate that is a candidate for release as a mainnet by the end of this quarter, that is by the end of this calendar year. And that will then pass through security audit. And once we're through security audit and have cleaned up any issues that arise there, then it'll be time for mainnet launch. So mainnet launch is in sight. This is a technology that's going to be available to people. And we've worked really hard to try to knock down the barriers to people actually doing effective development on this system. It works with Truffle. It works with other tools if you must. Other development settings. It works with 3 different wallets, and we have other integrations that are in the pipeline. So we're really excited about where this is going. We plan to do more, better, and faster. I talked about Arbitrum sidechains, but in 2021 and beyond, we have a chain of exciting features that will get us closer and closer to what is my dream in this space, which is the ability to run smart contracts in a way that is composable, that goes at almost the speed of a native computer without the overhead of a blockchain, and in a way that's fully trustless. That's our goal, and I think we're going to get there over time. So I'm going to stop in just a minute, but let me share with you some URLs where you can try all of this. If you want to try the Arbitrum testnet, it's at the first URL here, arbitrum.io/testnet. If you want to try our Uniswap port, you can go to swap.arbitrum.io and follow the instructions there. You can trade any token against any token or any token against ETH. We set up an Arbiswap token, which with an automatic faucet, which you can use if you want, but use anything you want. It's fully featured. And then finally, a link to our Discord. If you have questions or if you try something, you want support, it's not working the way you want, or you have questions, you can come there. We have a lot more documentation on our website, and our team is friendly, and we like to think of ourselves as helpful. So, we'd invite you to all do that. So, I want to come back to close just to connect the first part and the last part of the talk, the work that I did on a team at the White House and the work that I'm doing as part of the team in the startup. And as I said in the beginning, there's a lot more in common between these settings than you might think. You have in both places very clever, incredibly hardworking, and people who are motivated by the mission of the place that they're working. And whether that mission is to make the lives of all or some of the American people better in particular ways, as it is in the White House, or whether it is to make things people want and to build a business by doing so in a startup, what you have is a lot of the same kinds of people thinking a lot of the same kinds of thoughts and doing a lot of the same kinds of work from day to day. The work environment I found to be much more the same once you get out of the spotlight in either place, whether you're in public life, in government, in the White House, or in a startup. When you are in front of a camera, when you're in front of a microphone, you're communicating in the particular way that makes sense for that setting. But once you get behind the scenes, once you get with your coworkers, you have a problem to solve and you're standing or sitting around a whiteboard figuring out how to do it, or writing some code to try to solve some problem. All of that fades into the background. And at the end of the day, you're a bunch of people trying to solve a problem. and you're motivated to solve that problem because it is a thing you're trying to do, which is going to help other people do something more effectively or to have a happier or better life. I would finally just close by saying, if you're a person who is in the tech world, if you're a person who thinks of yourself as a startup person, that I would ask you to take a few minutes and ask yourself, is there something that I can do? Is there some way that I can contribute to making things better for the public, to participate in public service in some way? I found doing that to be an incredibly rewarding experience. I also believe strongly from being there that our government is as good as the people who go to work there. And if you have a gift, if you have something that you can bring to help make things better, that you can go there. And if you do that in the right way and you work with the right people, you can accomplish a huge amount, because although the government can be slow to get moving, it's like this giant oil tanker, which has incredible power and momentum once it gets going. The opportunity to participate in that and to do it in a way where you're motivated by the public good every day is incredibly rewarding experience. If you're a startup person, I would urge you to consider that. And I'd be happy to talk offline with anyone who wants to talk more about what that means and how it works. So with that, I will stop. I'll minimize this and go back to the chat. And if we have more time, I'm happy to answer any questions that come in through the chat. Thanks, everybody. So somebody asks, what is the performance of Arbitrum compared to XDAI? Here, I hesitate to do this off the top of my head because I'm not sure I'll get it right with respect to XDAI. I can talk about about the performance characteristics of Arbitrum in a little more detail and hope that that is useful. Basically, a way to think about Arbitrum, the current Arbitrum, as a rollup protocol. And what that means is that when you make a call to the chain, that the call data of your call, that is what it is that you're asking the chain to do, that needs to get recorded on the L1 chain. The L1 Ethereum chain is used to record call data. That's pretty much it. Everything else is done at layer 2. So at the end of the day, the majority of cost in a system like Arbitrum Rollup comes from the fact that you need to use some amount of call data on the L1 chain. We work super hard to compress that data and to get that down as far as you can get. But there is a fundamental limit to the cost reduction you can get in a rollup protocol. And that's why we want to go beyond that with the side chains. Let me just stop there. I'm happy to follow up more, and we can have a longer conversation about that one. Someone asks, is there a potential safety risk between layer 2 and the blockchain? So yeah, let me talk a little bit about how that works. And I'll do that with this diagram that's over here on the right side of my screen, which I think you can, I hope you can see. So the fundamental thing about how Arbitrum works, just to get to this safety issue, has to do with the role of the validators. So anyone can be a validator. It's trustless. You can come and get our open source validator software and just run it on your machine, and now you're a validator. And the guarantee that Arbitrum gives you is that if any one validator is honest, then the chain is guaranteed to, the Arbitrum chain is guaranteed to operate correctly. And the reason that's the case is that the way the chain makes progress is works like this: that one validator makes a claim about what the chain will do next. That is, what is the correct result of the transactions that have been collected at L1 in the Arbitrum inbox contract. Some validator makes a claim about what the result of executing those would be. It posts that claim on the L1 chain. And then there's a period of time, a challenge period, where any other validator has the opportunity to dispute that, to challenge it, if they think that claim is wrong. And so if there is if the claim is wrong and there's any honest validator, that honest validator will object to the wrong claim. And then the ARB rollup contract, which is also here, which is an L1 contract and runs trustlessly on Ethereum, that referees a dispute resolution protocol between the two parties. And that's guaranteed because of the properties of our protocol, and we have all kinds of papers that explain why that's the case. But basically, our protocol guarantees that the party who is right in the dispute will win the dispute. So what that means is any one validator standing up for the truth about what the chain will do will win and can force the correct execution. So as long as there is an honest validator available and operating at all times on your chain, then you don't have any significant safety risk compared to the layer 1 chain. Another question is, how centralized is Arbitrum as a whole and on the layer 2 level? And the answer is it's not really centralized at all. The entities that play a role in the security of the system are shown mostly here on this slide. There are these two smart contracts here, the inbox contract and the Arb rollup contract. Those are smart contracts. You can go and read their code. They don't have any admin key or backdoor that anybody can operate. They operate trustlessly and they do their job of collecting stuff. For validators, anybody can be a validator. There's a question just came in, will there be a marketplace of validators or will they need to be created for? And the answer is both. There will be a marketplace. We have a partnership with Chainlink under which Chainlink nodes will operate as validators. And we're in discussions with some other name brand infrastructure providers to provide Arbitrum validation as a service. And so if you want to hire that out, you can hire a validator or 2 or 3 for your chain. You can also be a validator yourself. You could run it on the test chain. You could run a validator on your laptop. That'll work fine. Or you can put it on an EC2 instance or something, whatever you want. So that part is not centralized because being a validator is trustless. There can be as many as people want there to be. The other party that is not shown here is what's called an aggregator. And that's kind of like a full node in Ethereum. Anybody can be an aggregator and any user can use any aggregator they want. Again, just like on Ethereum, anyone can run a full node, and anyone who wants to access, work through a full node via remote procedure call, they can do that and they can use whatever full node they want or run one themselves. So in Arbitrum, aggregators are the same. So there is no centralized component. There is no admin key or nothing that gives our company or anybody else any special control. We've worked really hard to make it not be centralized in that way. Okay, any other questions here? I don't see any more questions. I'd be happy to follow up with anybody later. Oops, I'm going the wrong direction. Okay, I see. I'd be happy to follow up with anybody later. You can get hold of us here. You can find me. My name is Ed Felten, so I'm ed@offchainlabs.com. If you'd like to email me, or if you want to talk to our whole team, Discord is probably the way to go. Thanks, everybody, and I hope this has been interesting, and enjoy the rest of the conference. Maybe I'll see some of you at poker tomorrow night.